your question, Ken, we're definitely pushing the envelope, and we're trying to basically pave the way for other leaders who want to build to net zero standards, and learn from our mistakes, and basically learn from our lessons that we've learned building these types of buildings.
Well, I think the industry as a whole will thank you for learning from the mistakes and helping provide some insights on some of those as well. As you said, this is sort of where things seem to be heading. Derek, you certainly have an interesting perspective on the project as well as the overall transition to net zero. In our brief conversations, I can tell this is something that you have a passion for, but I would love to hear from you at this point in terms of your view on some of the biggest challenges in terms of a project of this scope, but also from an industry preparedness perspective as well.
Yeah, it's an interesting discussion because there's so many layers in this. So brief introduction of my background. I've been on the consulting team behind Neil. We're one of the partners in the project. We're kind of a technology leaning company. And one of the biggest things we spend our time doing is building new companies. And I spend personally a lot of my time in the NGO world. Canada Green Building Council was an old place that I've spent a lot of time. I've been in the Natural Resources Canada committees for a while. I'm very involved at CHBA, the Canadian Home Builders Association's net zero programs right now, which affords me a generous perspective on sort of a broad scope view of what's going on across the industry. And then I try to keep my other boot dirty. The other half of my time, I'm on site building stuff like this. I'm very involved with the West 5 project, have been since the beginning. My involvement's been diminishing over these recent buildings because they've hired some really smart people like Neil who've been picking it up and carrying it. So I'm staying involved in the fringe. The bottom left corner of that picture is E-Park. That's a project that we're building on their site. What we're seeing across the industry broadly is very interesting. There's some consistent themes and there's some wide variety as well. This project's particularly unique benefits for the broader discussion are its scale. The fact that it is fully 70 acres and that there's a lot of different stuff happening in that 70 acres. In the top of the picture, you can see townhomes that are in normal row home format. In the middle of the picture, you see an 11-story building, and you see an office building that's 3 stories over to the right, and you see a parking garage of 2 stories. Like that, there's a lot of stuff going on here, and each of those buildings have different needs. And when you start evaluating those needs, you run into sometimes different questions, sometimes the same questions, and those are both interesting discussions. So what are some of the same questions? Trades readiness. There's an awful lot of trades who are involved in projects of this scale. Some of them are absolutely eager to do, like roofers and electricians are really, really eager to get involved with the solar industry. Some of them, like gas fitters, are scared of stuff like this replacing their jobs and don't see the opportunities for themselves and don't realize there are lots of opportunities in here for them. You start talking about transitioning guys who are used to working with gas over to working on heat pumps. Way less scary stuff, and they're very good at it. They just need some time to adjust. So we've seen a general, or I'll speak on my behalf. I've seen a general theme around challenges with trades, that there are a whole mix of trades out there. Generally, all of them are overworked. Everybody who's good right now has too much to do. And the guys who are available, we're naturally skeptical of. And then that's not always warranted. Sometimes it is, but sometimes it's not. And that's across the whole industry. And then that feeds into these code discussions as well. When we're trying to talk about, by 2030, we've got these carbon goals that we got to figure out, but we don't have the people to go and build this stuff. How do we get everybody trained? And how do we figure out where more Neils are? Because Neil he's not a dying breed of builder, but he's the exception. There are really good companies out there like Sifton, but they're not the norm. Everybody's under a lot of pressure right now, and it's hard to make time to learn. So how do you fit all that into the code and do it in a way where people can learn? Those are the challenges we're seeing. How do you ramp everything up and give everybody enough skills to get this done right? So these projects are important. Tours is something, probably one of the most valuable things Sifton has been doing is giving tours and letting people come and see it.
Yeah, you bring up the concept of trade readiness and training, and I want to touch on that a little bit later, because I think that's something that we're hearing across the country right now. Is obviously there's a significant skilled labor shortage, but the type of training that's going to be required when we start to see projects like this start to emerge as more, I don't want to say, well, more commonplace, I guess. Before we get into that, one of the things I wanted to quickly touch on, because being the Mechanical Contractors Association Canada, we often talk about the significant role the mechanical systems play in the built environment. They really are the circulatory system of buildings. but they also play a very important role in terms of energy usage. So just if taking it back a little bit to conception of this project and understanding the important role that mechanical systems play, how, Derek, Neil, from both of your perspectives, I guess, how important was it to address the mechanical systems when you were looking at this in a holistic sense, and achieving those energy reduction targets?
Yeah, Neil and I have both been to a number of building science events and conferences, so we can talk at length for this one. And Neil, you jump in and keep me honest here, but I'm going to say the biggest theme that I see is build tight and ventilate right. There are some slogans like that that are very helpful. We used to talk about how 50-year-old homes would breathe, and you don't breathe with your skin, you breathe with your lungs. Your buildings should work the same way. The mechanical system is not just circulatory, it's the lungs. There is a heart in this building, there are lungs in this building. If the skin is doing the breathing, you've got a really bad, poorly efficient building, and it needs to be fixed. Eventually you're gonna have water damage. Like, you don't breathe with the skin, you breathe with the lungs. So economizers, ERVs, are a big deal, and people need to get to the point where they just expect these things, and the contractors who install them need to get really good at calibrating them and installing them properly. We've got good contractors and we're proud of them and we stick with them. And there needs to be more good contractors out there who are very comfortable with these things and good at doing them. So that's just a start. There's a lot more there. Neil, why don't you jump in? What do you think?
Yeah, no, I think you hit the nail on the head, Derek. I think, one of the most important things when we're doing our energy modeling for these buildings up front, we need to ensure we are providing very energy efficient HVAC systems within the buildings. But I mean, 20, 25 years ago, when people were designing buildings, the HVAC load was the biggest load on the building. Heating, cooling was always the biggest load. Now that we're building these net zero type buildings that are extremely airtight, extra insulated, the HVAC load is no longer the biggest load. The lighting load is no longer the biggest load. The types of things that people are plugging into the wall, so anything you're plugging into the receptacles now within your home, and within commercial buildings that are to net zero standards, those are the biggest loads on the buildings. And it becomes an educational thing with the end users of these buildings, that we need to ensure that they're up to speed, that whatever they're plugging into their receptacles, those become the biggest loads on the buildings. So it's a different mindset now when you're doing your energy modeling and planning for these buildings. You need to make sure, first of all, that your building is very airtight, extra insulated, and then you need to look at things like providing an energy efficient HVAC system, energy efficient lighting controls, smart controls, things like that within the building. But it's a different mindset now because the HVAC load is no longer the biggest load on the building.
Yeah, one of the biggest impacts that has is you need to right size equipment. A
Yes.
lot of people in this industry, a lot of MCAC members are used to using tables or following manufacturer recommendations and not doing the math. And we cannot do that in these buildings. Like, we can't. The equipment will short cycle. It will not run properly. So we need to do the energy model, size the equipment to the energy model. And sometimes we end up fighting with the mechanical engineers because they want to use the tables and the tables don't work. They will force you to oversize equipment. And if you oversize the equipment, it will short cycle. So if there's people on the call who don't know what short cycling is, that's a good one to ask in the chat. We'll come back to it later, so I don't distract us now. But Steven's team, the Mitsubishi team, they spend time educating people on things like this, because you have to look into, you got to learn how to size the equipment properly and make sure that you're not just oversizing from some table somewhere. You got to design it for the building you're in.
That transitions us well to talking a little bit about the technology, and I think it's an important discussion point to talk about overall the education and training that's required for the industry to look at some of this stuff. But Steve, this sounds like a good opportunity for you to jump in and just talk a little bit about some of the technologies that Neil and Derek are talking about and how they're contributing to the overall net zero operations of the community.
Thanks, Ken. For the record, my name is Stephen Cornelius. I am the Residential Product Business Development Manager for Ontario. So I look after what we'd call mini split systems. So anyway, let's talk about this technology known as mini splits, heat pumps, and VRF. If you spend any time in warmer climates, you might have experienced heating or cooling, and that's usually from a heat pump. So for the record, this is not new technology. It's been around as long as a refrigerator. So if you take an air conditioner and if you give it a variable speed compressor, a reversing valve, some sensors, and logic, you have yourself a heat pump. So heat pumps and VRFs are systems that use the thermological properties of the refrigeration cycle to transfer heat from one space to another. So very simply, they're taking heat from one space and moving it to another. We don't create cold, right? We transfer heat. So the simple truth of heat pumps in their place in the net zero conversation is that they're the most efficient heating appliance, period. Electric resistance heating is only 100% efficient, right? 1 kilowatt in, 1 kilowatt out. Fossil fuel burners, they can never be 100%. There are always going to be losses. But heat pumps and VRF systems can be 200 to 400% efficient. So now if we go back to what we learned about refrigeration, refrigeration cycle, if you manipulate the properties of a refrigerant, the heat is captured from one space and transferred to the other. So the electrical consumption of the system is just used to run the compressor, the fans, and the circuits. And therefore, you're able to transfer more energy in the form of heat than you consume in energy.
So, speaking to that, one of the things we hear is that some of these technologies aren't going to work in certain types of projects, or I mean, given a country as large as Canada and with as diverse of weather as we have, aren't going to work in certain parts of the country. So what are your thoughts when somebody says that to you, that this technology won't work in their region or on a particular project?
Right, so it's the age-old statement that they don't really work when it gets cold. People have had experiences with heat pumps in the past where maybe they're in a cottage and whatnot, and be truthful, 5 years ago they didn't go down to past -10. But as we know, nothing stays the same. So how big was your first TV? How big is your TV now? And I might be dating myself, but the first phone you talked on, how far could you walk with it? Probably only as far as the cord would let you, right? So there was a time when heat pumps weren't good at low ambient, but now it's a different time. So our cold climate systems have been all the rage for the past 5 years, and Mitsubishi has been a leader in this pursuit to try to get lower and lower cold performance. So when a project is designed, we looked at the heating capacity or the heating output at winter design temperature, and then we sized the system for that. So there's heat pumps right now in all regions of Canada, north, east, south, and west.
This might be a good opportunity at this point to talk to Brent a little bit, because Brent, from a contractor's perspective, and I think your point of view on this is something that many of our members will have interest in. What was it like for you when you started dealing with some of these new technologies, and perhaps technologies that you weren't overly familiar with at that point?
Yeah, for sure. It was stressful at first, to be honest with you, because we hadn't really installed any of this stuff before. We did a couple of mini splits here or there, but that was about it. So we really weren't too confident at first, but Sifton gave us an opportunity to kind of grow from there and learn from it. When we looked into it, we had all the right equipment. We didn't need to go out and purchase a ton of new tools or anything like that. We had everything we needed to do it. So we said, yeah, we agreed to it. Once we had the equipment, we kind of put a plan in place, where to put the equipment outside, inside, you got to insulate both lines. But there's a lot of things we didn't have to worry about, like clearances from gas meters, intakes, exhausts, all that. So once we installed a few of them, it actually became easier for us, I guess. Easier and quicker. It saved us a bunch of time. And then once we had them up and running, we had some pretty cold days. I think one day was -26 or so, and the heat pumps were performing and keeping the homes consistent. There are electrical backups, but they weren't running. The heat pumps themselves were actually heating the homes perfectly. So it was kind of a shock to us, but in the end, I'm glad we decided to do it.
So, I mean, looking back on that, you talked a little bit about sort of the trepidation you may have had to step into this and get involved in a project with some new technologies. Is there anything that you, from a contractor's perspective, can share as sort of a broader lesson learned, or maybe there's something that you wish you would have known heading into the project that, you know, now that you do know it, you're like, okay, well, this is this old hat almost.
Yeah, most important thing I think was a good flare, to be honest with you, when hooking up these units, because you know, doing with gas, you can do a lot of different things. You can squeeze it tighter. You don't have to have that perfect flare, but for us, with the high pressures, what we were finding on the first couple is that we had some small leaks. So once we discovered that, then we decided to make sure that our flares are, you know, perfect before we actually hook them up to the units and cut them off. And then you know, so we don't have to cut them off and start shortening our copper. Yeah, so there's that. The other would be elevating the units, because you have to elevate the heat pumps. So with new construction, you can't just put a stand down on the soil. You can't put it on patio stones. It's going to settle. So for us, it was trying to find a bracket that would fasten to the foundation, go up over the brick and out, which they are out there. When we first started, we didn't know, but we were able to find some, and it made our lives a lot easier. Saved the builder money, saved us time, and we were able to install them before, you know, they even graded the properties. And then I think confidence. If I would have known earlier how well these units work, I would have been a lot more confident talking to potential customers or clients. Just knowing that this equipment really works, it makes a big difference with talking to people.
Can I, going back to one of the points Derek made about a trade readiness perspective and component, how, from your point of view, what was the trade readiness situation like from your perspective in terms of getting into this? Was there a lot of new training that was required, or was the skill set there that just new systems?
There really wasn't a lot of training. You know, Mitsubishi had us in for a day just to kind of go over some important tips that we definitely took advantage of. But to be honest, the skills set was there. We just needed to believe that it'll work. That, you know, running a line and banking, then running a line set 80 feet, you know, up through an attic, it is going to perform properly. And once we were able to see that in person, it made it easier for us. But as for training, there's a little bit, but there's nothing crazy that we don't already know. You know, we've been putting in central air for how many years? It's basically the same type thing. You just have to look at it a little differently.
Right, because I mean, this is one of the challenges that we often are talking about as we talk about this, a transition to net zero or increased energy efficiency, is the availability of the skilled trades, but not sort of downsizing the skill set that already exists across the country. We don't want to take away from the skilled trades that are already there, or suggest that some of this work can be done by unskilled trades. So, but it's an issue that it continually comes up, is how are we going to find the workers who are going to be, you know, skilled to the point that they can do the installs, they can do the service, they can be a part of this transition to net zero. Maybe Steve, from your point of view, then what does that training look like as we're making this transition to net zero? Are there specific roles contractors should be looking to fill that they should have in terms of on their staff and in their skilled trades?
Well, as Brent mentioned, you know, if you've put in an AC, you should be able to put in a heat pump. Those skills are transferable. From our side of things, when we're looking at training, you know, we have guys in. It used to be, it's the training's been shrinking, but it's generally 2 days, and really you're there to learn about the wiring, the controls, and what to look out for. As far as future proofing, in my opinion, contractors should invest in learning how to integrate the carbon technologies into the existing spaces. So an ideal contractor for me would be familiar with all the new methods of heating and cooling a space, and water as well, and maybe be able to provide access to PV and alternative water heating measures, and then integrate all that with controls.
Being cognizant of a few questions that are coming up, so I'm going to try to get to some of the questions that have come in, as well as sort of keep our conversation flowing. Gordon McDonald has asked, net zero seems to be mainly focused on the carbon footprint after the buildings have been constructed. Is the next step for net zero to look at what goes in the actual construction, and ways to use greener installation building techniques? Right, there's a question, there's another subtext to that question, is how do we deal with things like embodied carbon in some of these materials and in the projects? And Derek,
That's a lively one.
I was going to say, without putting you on the spot, Derek, I thought you might be perhaps the best person to talk to some of that.
Yeah, happy to. You can imagine what these debates sound like when you get into the national committees. You've got voices from every perspective. There's lots of lobby groups and interests reflected, and everybody's got a different need. And the biggest challenge of policymakers to sit in the middle of all of that is to respect all the competing needs. And obviously, our existence as a race in this planet is important. So we gotta figure out how to deal with this stuff. But at the same time, people need a place to live. And it's very hard to make people care about big global topics when they're having trouble putting food on their table or having a table to sit around. So we have lots of competing interests in this discussion. I'm going to suggest the most practical discussions that I have seen that flow most quickly into action are the ones that have the closest feet to the ground. And energy is a winner all around the table. You can argue all you want about where the energy comes from and source versus use, but if we just get to zero energy, all our energy comes from site, everybody knows that's a win. Everybody understands that that's creating local jobs, that's creating independence, it's good for the grid, it's just good. So just do it. When we start debating about carbon in the materials, the debate gets really mucky because there's some people who are very qualified to tell you how much carbon is in a material. There's other people who are very motivated to make you not consider various externalities that you might need to consider. And so we spend a lot of time arguing about, okay, who defines what carbon counts? And if you're going to talk about scope 1, 2, and 3 emissions, how far are you going to chase the train? And if I'm going to go through, let's use Stephen as an example because his equipment is sophisticated and they've spent years refining it. Heat pumps are, I'm going to reiterate to his benefit, heat pumps are not new. This is an old idea and it's got a lot of experience now. We do this well. The industry is very ready to use heat pumps. But what is a heat pump? It's got metal in it, it's got circuits in it, it's got wires in it, it's got pressure systems in it, it's got parts that come from literally all over the world. So if you're going to try to figure out how to measure the carbon impact of installing a heat pump in a building, like who says what scope counts? And do I have to count the transportation from the site that excavates the material that goes into 3 different raw processing factories that leads off to the production of a chip that goes into a circuit board that what? And most people don't even understand the supply chain, let alone trying to quantify it. And that's a lot of work for even the most talented people. So you can imagine the debate's lively and how far do we care, right? There's a very obvious benefit to using Canadian Western wood. Done. Okay, we get that. That's good. Let's use wood. If you're in Southern Ontario, use brick, use recycled steel. There's some things here that are pretty obvious. The impact of these things can be measured meaningfully, but a lot of this stuff is so complicated. And honestly, I think it wastes time. And so there is a noble policy effort here, but the most noble effort is going to be around very practical things. And then the rest of it gets quickly into politics. And then we got to argue about international supply chain pressures. Like what happens if half of the equipment comes from Ukraine or Russia or anywhere impacted by those two? What about China aggressing on Taiwan? Do we have a moral lens that we're going to apply to our carbon? It just gets complicated. So in the committee environments, there is a definite movement towards finding ways to measure these things. So we can talk about embodied carbon in the code, but I'm going to argue the industry as a whole is far too divided for this to show up in code anytime soon. What we definitely have opinions on that are consolidating around sort of like the coalescing into a direction is how much carbon we use after. If we talk about building a building that is a good building that operates at zero carbon, zero energy is even better than zero carbon. For a whole list of reasons we can talk about later. That one's meaningful. We can define that. So I push for that when I'm in the committees. Most of the committees that I'm on, people resonate with that fairly quickly. And embodied carbon is coming, but it's going to be a while. That's what I think.
No, I think that's a valuable point of view because it does convolute sort of the discussion around a lot of this stuff. And I mean, if we simplify it, and maybe Neil, going back to you for a second, because I know I've heard you've mentioned this before, is the need to shift that mindset around building a building. So simplifying things, and particularly in the context of capital investments on some of the material and some of the equipment that's going in there, what's the advice that, as from an owner or developer's perspective, that you can offer that says this is the right way to go to help achieve energy reduction targets? But from a capital investment perspective, how do you see that ROI?
Yeah, from the capital investment perspective, West 5 is pretty unique, in which all the buildings within that development are rental buildings, at least the ones that we own. Derek, on the other hand, he's building condominiums, so he can speak from that end. But on the rental side of things, we're investing the money on the Mitsubishi units because our tenants are actually paying out of their pocket for their energy bills. And what we've heard from our tenants is that during the winter time, it may be comparable, if not a fraction less, during the winter time to heat their space or heat their unit compared to a similar sized unit. But in the summertime, to cool their space, they're basically a third of what their normal energy bill would be. So these heat pump units to them are definitely more energy efficient and less money out of their pocket. But from our standpoint too, in our first phase of the townhouses that we developed, we used a competitor's product to Mitsubishi, and there were some major service issues and warranty issues that we had on that particular product, in which we were investing money out of our pocket. With the Mitsubishi product that we've implemented on the second phase of townhouses that we've developed, we haven't had anything out of pocket. So maintenance service on these things, and Brent can attest to this as well. We install them and we're done, and we haven't had any issues with those particular units. So yes, we might be spending a little bit more money up front, but maintenance and providing a lesser energy bill to our end users is more important to us. So
if I can pick up really briefly on that, I think one of the things that you just heard Neil say, that I hope you realized you heard Neil say, is how important his suppliers have been for him. And I would definitely agree with that. And I would say in the committees I'm in, I see that across Canada. Number one for us, if we're going to adapt new technologies and transition into new approaches or new ways of thinking and building, we need good people we can trust all around us. Neil started with a strong relationship with Brent's company and told them, we want to do these heat pumps. Our design team says we should do this. Hey, Brent, we still want to work with you. Like, I had a good relationship, had a good local contractor you could trust, asked him a bunch of questions, didn't get any red flags. Then they tried it. And they made a mistake with the first one. They didn't, but the supplier did. And Sifton had to recover from that. So who did they go to? They went to Brent. And with Brent, they went to their consulting team and they got advice from the people they trust. You guys as MCAC you're important. You guys as members and people listening to this call, the role you play is very important here. And that's why companies like Mitsubishi are here, because they want to be part of this discussion. They want you to know they're going to support you. And I would suggest heavily that one of the most important points in this experience was the support. Neil turned around with a problem and got prompt answers from one company, not the other. So he switched and he kept the same contractor because he knows and trusts that contractor. Like there's some themes here that are not just Neil, but he's a very good example of it. And I think this is where MCAC members should be hearing an opportunity. I mean, there's a very important role that you all play in the energy transition. And if we're going to bring in new technology, we need you guys to be first and foremost knowing how to use it, because you're going to be the guys we call when we need maintenance help. And heat pumps are heat pumps. They need maintenance. They don't need a lot of it. If you install them right, they're not going to need it often, but they do need maintenance. So we need the right people to know how to do that. So just make sure you heard that. Your role is very important here.
Yeah, that was going to be one of my points, is that, I mean, speaking from the Mechanical Contractors Association of Canada, selfishly, what I heard was contractors are doing a great job, and there's some breakages earlier in the process, or disconnects early in the process that are where the problems will lie. So I guess a question maybe to Derek and to Neil, either one of you, from an overall industry readiness perspective, are there certain stakeholders that are not quite ready to adapt to this or jump into this, that as contractors we should be aware of, or be mindful of, in terms of where we might see some disconnects?
Yeah, Neil, I just had a turn. You want to go first?
I was going to turn it over to you, Derek, but
Sure.
I think from an end user standpoint, if guys are just going to go out and keep building the same type of thing that they've been building for 15 to 20 years, then they're going to be very hesitant to incorporate this technology until it's forced on them. I think it's going to be the forward-thinking companies like ourselves that are willing to adapt and willing to provide energy efficient homes for people to live in, because we are forward thinking and we're thinking ahead of the curve a little bit. It's going to be those guys that have been building the same code standard buildings for the past 30 years that are going to be challenged to incorporate this type of technology until the government or a entity steps in saying that you have to build things this way.
Yeah.
So I think that's going to be the biggest challenge.
I think that's true at every level too. Yeah, you described it well for the builder's perspective, and I agree with that. I think it's also true at the engineer's level. There are some engineers who are very proactive and creative. There are others who are bidding, bottom dollar bids, trying to be really competitive and shave their bid and recycle as much as they can out of their last design, and they're not sizing things properly. And there are I mean, you guys know it. You've got members around you who are really proactive, who earn awards and are leading and giving good example. And you've got others who are dragging their heels and kicking and screaming about every little change that comes their way. And then you've got them in the same company, where dad built a company and son is taking over the company and they don't agree about the direction they want to go. I mean, you guys have seen it. So I would say this happens at every level. I would say that creates, again, an opportunity for, MCAC members can stand in the middle of all of that. And I would suggest, because of where you fall in the supply chain, and because often the design is done before you have a say, that's not your fault. It becomes your responsibility. We've all been part of those arguments. I know it's not always fun, but it's a very appropriate and wise question for you guys to say, how was this stuff sized? Did somebody just check to make sure? Like, we know the building codes are changing. I'm seeing weird stuff in my projects sometimes. I'm not the engineer. You're the I don't know, but did somebody check to make sure this is sized for this building, not just out of a table? That's a really smart question you can ask every time, and you will never get in trouble for it. And you wave your hands. All right, I'll just install what I'm told to install. That's what my contract says. I'll just do it. But you're going to get the maintenance calls if they sized it wrong. And so just ask the question. It's a good question for you to ask. It makes people think. It's just a good use of your time. And if you've got time to be proactive, I would say call the suppliers. Mitsubishi is not the only heat pump supplier in town. They are the one on the call, and they're good. But you can definitely ask questions around and figure out what different suppliers are doing. And Mitsubishi has gotten good because they've had some pressure. They've had some competition who's been trying to eat their lunch too, and the industry grows that way. And Mitsubishi's worked hard to grow, but again, we like to keep them honest. We like to ask them hard questions, and they like to come back with really good answers. It makes good discussion. But you guys have supply relationships. Push them. Ask them good questions. What are you doing about heat pumps? How has it gone? What are your service calls looking like? What kind of problems have you had? What are you doing about that? You guys are right in the middle of the real life version of this, where the architects and engineers are done making pretty pictures and you got to live with it. So, ask good questions on the I got to live with this level, and you'll be a big help to the projects.
Yeah, you're taking some of the questions out of my mouth before I have a chance to answer or to ask them, Derek. So I mean, I appreciate that. I'm gonna keep up with some of your notes and some of the comments you're making, because I think that was one of the things I wanted to talk about was, for a contractor, what advice do you provide who perhaps they haven't been involved in a project like this? And then I also wanted to sort of touch on with you, Neil, is there a type of project from your perspective that works better? And when I ask that type of project, is it a design build is going to be more suited for projects like this, or for meeting some of these targets? Is a construction management going to be a better project for something like this? Or will this still work in a traditional design bid build situation, but you just have to have the right team in place?
Yeah, I think it works in both scenarios that you outlined there, Ken. Having a good team is key. Having a mechanical consultant up front that understands the systems, that understands what Mitsubishi or another heat pump supplier is able to bring to the table, and writing their specifications around that, to be able for us to go out to people like Brent to go and install those types of systems. I don't really think there's any right magic to it. I just think you need to educate the consultants. You need to educate the people that are actually going to be installing the systems. That's the biggest thing. One thing that we haven't done as a builder is retrofitting. So we haven't actually gone into existing homes and installed a heat pump system. That's one thing that I can't attest to, and that's one thing that is probably quite challenging. But from the design build standpoint that you've outlined, I mean, it really comes down to having a good consultant and having a contractor that's either well educated or willing to learn.
One of the questions in the chat that I think it can be expanded on. Eric Niemi has asked, from a contracting perspective, are we going to see consultants move towards more performance-based specs instead of prescriptive specs? And I think I would take that question a step further as well. Is what should contractors be aware of if they're going to start to see more performance-based specs on some of these new technologies? Any red flags that they should be aware of or mindful of if we see this transition? And I guess I would open the floor, not to anybody in particular, but anybody who has some insight on that.
Well, I guess I'll step in here. With regards to performance, when you see that in a spec, you want to make sure that anything that you're going to be bidding is properly qualified, so that it's maybe peer reviewed, or it's something that the manufacturer stands behind. Because on the market materials, I'm not saying that anybody's dishonest, but there can be some numbers in there that might be rounded up or rounded down, whatever the case may be. But you want to make sure that the performance is something that is stood behind, and that way when you put something in, then it's going to meet the spec.
Brent, I haven't picked on you in a while, so maybe I'll go back to you really quick from your perspective. To that point, I'm not sure if you've had to deal with this so far in terms of performance-based specs, but what concerns would you have as a contractor, or did you have perhaps on this particular project when you started to get into it, when you see technologies that are new or something you haven't necessarily used yet?
Yeah, it's mostly just confidence. Like when we spec out the stuff, we'll talk to the manufacturer because we're not comfortable sizing it the first few times ourselves. We can do a heat loss, and then we'll talk to somebody from Mitsubishi or another manufacturer to size up the equipment properly. If it's a retrofit, you got to take into account what size ductwork's currently there, and just in the age of the building. There's a lot of little things when it comes to this transition, I think, that we're not super confident on. So we reach out to the manufacturer, and from there, they help us through. They can size it up for you. They can give you any tips on what you should and shouldn't do. If maybe you should change some ductwork, maybe you shouldn't. So for us, it's just good having a good relationship with the manufacturer, because they help us through a lot of these types of things.
Apologies, I was on mute. And I think one of the insights I would be interested in hearing from you is, what has been the biggest advantage for you and your company working on this project and with this new technology? And have there been any sort of significance or positive surprises that you weren't anticipating when you got involved?
Yeah, I mean, positive surprises, quicker installs, at least on new construction, right? We're not having to run main lines, you know, across the building. So in West 5, there are townhomes. So what we did is we were end banking all the heat pump units. So some of those line sets were about 75 feet long. So if you had to do that with gas, you're running your main line hard pipe through all the firewalls into the building. That's going to take a lot of time. With this, it was just you run your line set and run it to where your unit's going, hook it up inside, and that was it. So the other thing is how quiet these units are. You could put it right outside the master bedroom and open a window and you can't hear it. In some of the other phases, we had some on decks and porches. Not one complaint about noise. Like I said, it starts up and you cannot hear it. You have to physically see that fan going to know that it's running. And then the other thing is for new construction is clearances, especially condos, things like that. You don't have to worry about your gas meter being in one spot, your ERV intake, your tankless water heater, exhaust to the furnace intake, anything like that. There's nothing. You just basically can put your ERV intake and exhaust, put your heat pump in the middle, beside it, in front of it, anywhere. And again, you don't have to worry about the noise issues or anything like that, which nobody likes putting an air conditioner on right beside someone's back deck. But with these, you won't have an issue with that because you can't hear it.
No, I want to be mindful of everybody's time, particularly our panelists, as well as everyone who's come in and joined us for this. So we have seven more minutes, and this is what I feared was going to happen. Is I have a lot more questions, and I'm sure there's quite a few people that have other questions as well. But I do want to try to open the floor to the panelists one more time for sort of final thoughts. But I'll toss this at each one of you: is where does the industry go from here, from your perspective? We're talking from the Mechanical Contractors Association of Canada point of view today for us, but what needs to be done from your various points of view in order for the industry to be ready to take this on in a broader scope? And maybe I'll start with Neil. I'll go to Brent, Steve, and then Derek.
Yeah, I think what we're doing now is the wave of the future. I think, there are going to be, like I said, a lot of builders and a lot of developers that are going to be very hesitant to continue or to go down this path. They'll just continue doing what they're doing. But I think they can come to, people who are hesitant to do this can come to people like us who have done it and learn from the mistakes that we've made and the lessons that we've learned. I think it's very important for us to get together as a building community and share our experiences in developing these types of things. Derek has started his development, and he's taken a lot of the lessons learned that and the mistakes that we made along the way and implemented it into his development. So I think that we kind of are blazing the trails right now at Sifton, and we're willing to share and bring people out to see the community so that others can learn from us. So
that's great. Thank you, Neil. Brent, your thoughts, sort of closing thoughts on some of this, and where do we go from here?
Yep. I mean, a lot of us, I'm sure, have probably been through these types of things, info sessions, courses, things like that, where everything sounds great, but does it actually work? We were lucky that Sifton gave us time to actually sort the stuff out and figure it out ourselves. And it does work. We're typically a company who has to physically do something to actually believe in it. And we've had gas guys out there running copper. We've had sheet metal guys doing the tin work, and then the air conditioning guys as well. So we've had all of our guys out there working on this equipment. I think the biggest thing that we got to take out of this is getting confident with this type of system. The way that they're phasing gas out, the way that gas prices are constantly rising. This is the way that it's heading. So we might as well get ahead of it now and just start doing it, even if it's just a mini split. Do a mini split for a friend or something like that. Get comfortable with the equipment, and understand how it all kind of connects together. And with that, you'll be laughing in a few years, just with customers and clients and things like that. I think confidence in us as contractors are one of the bigger things to take out of this.
I mean, it seems to be well established. There's going to be a significant role that contractors are going to be playing from the install to the service, repair, and maintenance on all this stuff. So that confidence is going to be key. Steve, what are your thoughts on this, and where do we go from here?
Well, I think people have to change their mindset. Like, don't think of this net zero thing as something that's being forced down your throat. There's logic to it, right? If you can heat and cool a space more efficiently, then why not? From a homeowner's perspective, if you can, if you had PV and everything was a perfect setup and you could create more energy than you're using, get rid of your gas bill and then get a credit on your electricity bill, why wouldn't you? So there's logic to it. So don't think of it as a bureaucracy or anything like that. Just start adapting to the change, because it does make sense.
Derek, any final thoughts from your perspective?
Yeah.
Touched on?
Well, there's so much going on in this space all at once. It's interesting to think about the general technology adoption curves, right? Like, once upon a time, cell phones were new. Once upon a time, automobiles were new. Homes are not new. We've always lived somewhere. But the way we build homes has been changing a lot in the last 20 years, and it's affecting most industries. So if you look at the adoption curve, we are not anymore in the super early adopters. We're in the early majority for things like heat pumps. If you look at net zero, it's still early adopters. There are hundreds of them across Canada, not millions. Okay, fair enough. There are not millions, but there are hundreds. Yeah, you can go and see these in every province, in every major city. Every builders association now across Canada has an award for green buildings, and heat pumps are an old story there. That's not exciting anymore in the green building awards. So this is the kind of stuff that, yeah, we're into early majority. People need to understand this is not just a big scary thing that's coming. It's long been here. As Steve mentioned, it's decades old. Space technology was using this in the 50s, and it's been as long as fridges. And like, this is not, anyway, we don't need to rant. So my point is, it's already late. Like, if contractors are pushing back on this, it's like pushing a noodle up a hill. Like, it's just a useless fight. Do not fight it. And you guys already understand you're late in the supply chain. The architects and engineers have made a lot of decisions before you get called to bid. So what I would say is, relationships are always the best place to learn. You guys all have contracts with people who you like and with people who are hard work for you. So I would talk to the people who you like. I would, you go to your association meetings that you go to the NGOs you participate in. If you're building homes and you're not in the Home Builders Association, get in the Home Builders Association, go to the meals and the lunch meetings and the dinner meetings in whatever local groups you're part of, and talk to people there and figure out what they're doing, figure out who the people are that you can learn with. And if you're already on the path of learning, follow Brent's example. This is not a hard skill set for contractors who are part of MCAC. And if you've got experience dealing with gas, then you've got experience dealing with something that is literally and physically explosive. Like, it's a totally different and much higher risk category of work than what we're talking about with heat pumps. This is actually easy for you. And as soon as you get your head around that, it's not a big deal. The steps that you go through are simpler and more defined steps. They're just slightly different steps than what you might have been used to before. So, lean on the manufacturers, go to the training events, absorb a couple of webinars. There's a gentle learning progression here. It doesn't have to be scary. So I would say, don't be scared. Brent's a great example of a normal contractor who has a good history, has worked hard, was busy, didn't have time until Sifton made time for him. And he learned, and now he's like stable for them. Like, he's a necessary asset in their team. So you guys want to be necessary assets. You stay ahead of this, it'll be a really good thing for you. And you'll be a good thing for the industry. And the only, sorry, get off my pedestal here. The only other thing I'll add, in a labor shortage, there is no room, no time, and no use whining and bickering about things that are going to go and disappear. Like, it is an absolute waste of time, and you are a problem if you are telling people that we need to protect gas jobs. We will have lots of gas jobs. They're not going away. We need to build twice as many homes as we have been building for the last 10 years, and we need to do them all in 10. Like, that's a stupid high number of homes. Like, there's a lot of work to be done. So no matter what role you've played in the industry, there's a lot of value you're going to contribute in this transition, and nobody is going to be at risk of losing work. If anything, we need more of you. So there is no point pushing back. There's only opportunity here. for you guys as contractors. There are lots of other challenges for other layers in the industry. They're not yours to worry about. I think you guys are the practical people. You're the dirty boot people. Like you're the people who are on the ground telling us what really needs to be done. Stay in that role, stay in that lane, ask good questions, get free training. It's only opportunity for you.
Brent, I don't know if you heard that, but Derek called you a normal contractor.
I hope that wasn't insulting. I'm trying to use you as a not scary example.
No, that's perfect. That's perfect.
I think this is one of those discussions that isn't going to end here, and I'm hopeful that we'll have an opportunity to bring some of you guys back to talk about some more of this stuff, because it's certainly not a topic that's going away. It's one of that's going to continue to gain interest, I think, across the country and throughout our industry as we see more owners and more buildings transition to this net zero and to increased energy efficiency. So I guess from MCAC's perspective, I want to thank all of you for joining us, for being here today to share some of your insights on this topic. And once again, I want to thank our sponsor, Mitsubishi Electric Heating and Cooling, for helping us to put this on. As I said, I don't think this is a topic that's going away anytime soon. So appreciate those insights, some of the pep talks as well, because there's been a few points there that I've written down that I think are very relevant and going to be important for some of our members to hear. So again, thank you for being here. Thank you for joining us. I hope all of you have a great rest of your day. For those of you in southern eastern Ontario, hopefully the snow blowers are, well, if they're electric, I'm not sure if they're going to work, but if they're gas fired, I hope they're filled up and ready to go, because I guess we're going to get hammered tonight. So in the meantime, thank you all, and we'll be in touch soon.
Thank you.
Have a great day.
Thank you, everyone.
Thanks, everyone.
Thanks, everyone.